All right, welcome back to the morning show. Time now for a little science. And many of you have fluorescent lights in your home or in your workplace, but do you know how they work? Well, Jesse Miller does, and he's here. He's a teaching lab specialist and REACT program director at the U of I. First of all, what's the REACT program?
It's a program that's reaching and educating America's chemists for tomorrow.
Okay.
And we go out to the third grade, fourth grade classrooms and do some chemistry with the kids. And we have all sorts of programs. We work at Don Moore's Boys and Girls Club at times, Girl Scouts, Boy Scouts, all sorts. It's a
Get
pretty
the
big
youngsters involved.
That's correct.
All right, fluorescence. What do we got today?
Okay, well, we got several different types of fluorescence. Actually, it's all fluorescence, but we kind of categorize them different. We have our classic fluorescence, and there's phosphorescence, which I'm not going to really show phosphorescence, but and then of course there's bioluminescence or chemiluminescence, which I'm going to show over here. First of all, we'll show some of the fluorescent. Now here, these are discharge tubes, and they're filled with different gases. We have neon and argon and xenon and krypton. I believe it's krypton. Yes. Or no, that's hydrogen on the end.
I was going to say, because Superman doesn't want that one, right?
That's right. That's why I did. And each of these gases, or each element, when you excite the atoms, their electrons go to a higher energy state, and they come right back down, and they give off a wavelength, or several wavelengths of light. And if you want to turn that on down there in the bottom, these are high voltage, so don't touch them. And you can see they have some different colors. We got the neon here and the argon. And they're emitting light, and that's fluorescence. As they de-excite, they give off light, and of course this is going at 60 cycles per second, so we see a lot of events going on. Now, phosphorescence is very similar, except for it kind of goes into this quantum holding pattern, if you will, and then it takes longer. Instead of de-exciting at picoseconds, it goes in seconds and minutes and things like that. So phosphorescence is very similar, but it's a little bit different. Now, go ahead and turn that off.
Okay.
It makes me nervous. All right, so there are other ways that we have, we have glow-in-the-dark things, right? And those are all fluorescence as well. Your shirts, your white shirts, when they have brighteners in them, actually have a dye that they put in the bleach that fluoresces. It doesn't really make your clothes whiter, it just makes them shine. So when the light hits it, it fluoresces out. And some things fluoresce in UV. If you had a black light at home, I'm sure you did.
Way back when.
Some things fluoresce. These highlighters actually fluoresce in UV. So if you want to write somebody a note here, something on there, we'll see that here in a second. And as you can see, I did it on yellow paper. I had to do it on yellow paper so you couldn't really see it. But if we turn the black light on it, you can see, I don't know if you can see that very well. This was it.
Can you read it?
Can you read it? I can't see on the TV.
It reads, "Hi, Ann, go Sox."
So it's fluorescing due to ultraviolet light. And like I said, some things fluoresce at ultraviolet, some things fluoresce like at the whitener in your clothes at a bright light. And of course, then the last thing I was going to show you, you got a light stick here. This is chemiluminescence. Okay, now instead of using light or electricity in order to cause the excitation, we use a chemical reaction. In this case, it's hydrogen peroxide, and there's a little ampule in there. If you break it, and shake it up, then it starts glowing. Okay, and I'm going to show that here in a kind of a behind-the-scenes type of reaction here. This is luminol, and actually I don't know what station CSI is on, but
it's okay. I think it's on ours. They have like 3 of them.
I know they're all over the place now. It's real popular. But anyway, you see them. They use luminol to show up blood. And when luminol complexes with the iron, and we use copper instead, and they'll spray the luminol on where they think blood is. Then they put an activator on there, and it glows, or under black light. But we want it to glow a little bit more spectacularly. Can we get the lights down in a second?
All right. You're going to be able to pour, you okay?
Yeah, well, yeah, I believe so.
All right.
Okay, so I have the luminol on the one side, and I've got hydrogen peroxide on the other as an activator. And when we mix them together...
Whoa.
It's kind of cool.
Very nice.
And there we go. And this is the same process that lightning bugs use in bioluminescence.
Very cool. Well, thanks. Those are some cool experiments. We'll have more on plasma stuff coming up in 30 minutes, right?
That's right.